Okay, guys, so this is a supplemental aid that I want you guys to reference when you're first starting to do stoichiometry problems. So we're going to go ahead and fill in some information here. We're going to start with the mole map. The mole map is a visual representation of what the different unit conversions are. So we start with our unit conversion in the middle, which is the mole, okay? And you'll notice that all of our unit conversions are based off of 1 mole, okay? So then the mole is our essential unit that we use to convert. We also have these 3 measurements here. So we're going to go ahead and start with volume on the right, okay? So if we want to convert from moles to a volume, we're going to use the following conversion factor. We're going to say that 1 mole equals 22.4 liters. Okay, so that's the conversion factor for volume. Next, we're going to talk about particles. Okay, for particles, we say that 1 mole equals 6.02 times 10 to the power of 23 particles. And we have 3 types of particles in chemistry. Okay, one of those particles is formula units. Other particles that you're probably thinking of are atoms, and then you're probably also thinking about molecules. Okay, so those are the 3 types of particles. And so for all of these particles, right, we would always use Avogadro's number. Okay? The final measurement that we use to convert is mass. Okay? And for mass, we say that 1 mole will equal the molar mass of that element or that compound in units of grams. Okay? Now, how do you find molar mass? Well, molar mass for elements you're going to use the atomic mass that's on the periodic table. However, if you're trying to find the molar mass of a compound, you have to add all of the molar masses together. Okay? And that pretty much sums up this anchor chart. Okay? So for mole map, again, there are 3 major measurements that we need to convert to and from in chemistry. The mole is our central unit. It's a universal unit that helps us convert easily between any of these 3 measurements, okay? These are all conversion factors, okay? They're statements that tell us how much a mole is equal to. When we're converting between moles and volume, we say 1 mole equals 22.4 liters. When we convert between moles and particles, we say 1 mole equals Avogadro's number. When we convert between moles and mass, we say that 1 mole equals the molar mass in units of grams. Depending on what we're looking at, if we're looking at just elements, we're going to use the atomic mass from the periodic table. But if we're looking at a compound, like for example, sodium chloride, we have to add all the individual atomic masses of the elements in the compound. I just realized I wrote molar here. I meant to write atomic mass. I'm gonna fix that real quick because I don't feel like restarting this video. Yeah. Okay, wow, I butchered that. Okay, let me learn how to spell real quick. Together. There we go. So that's pretty much it. And so stoichiometry, which is what we're learning today, has to do with these mole conversions. And we're going to talk about stoichiometry up here now. So I want to give y'all a simple chemical equation. I'm going to give you guys the synthesis of water, which is made from hydrogen and oxygen. So if you remember correctly, hydrogen and oxygen are diatomic, meaning that they all require a subscript of 2. So here we have hydrogen, there we have oxygen. So those two molecules are going to react to form the compound water, okay? Then we also have to balance this chemical equation. You have to remember the goal of balancing is to ensure that we have an equal amount of atoms on both sides of the equation. When we don't have an equal amount of atoms, we're going to multiply by a coefficient that is going to give us more atoms and make everything even on both sides. So we're going to take a look and say, hey, I don't have enough oxygens. So what are you going to do? You are going to draw a 2 here, okay? Now, 2 times 1 gives you 2 oxygens here, and you already have 2 oxygens there. Next, you're going to look at the hydrogens. Let's see, we got 2 hydrogens on the left. We're going to do 2 times 2. We have 4 oxygens on the right, meaning I need 4 here as well, so I'm going to place a 2 there. And then, since I don't need to do anything to this oxygen, because I already have enough, right, we're going to place a 1 right there. Okay? So that is the balanced equation. So now, what we're trying to get to here is we want to make sure first that we understand mole ratios. For example, if I ask you guys, what's the mole ratio in this balanced equation of water to oxygen, y'all got to be able to tell me that the mole ratio is 2 to 1, right? Mole ratios are based off of coefficients. Maybe you want to write that down. Maybe you want to remember that. So you're going to say mole ratio look at the coefficients. Okay, this was the lesson we did last class. If you weren't here for that, shoot me a message because we also took a quiz and you probably owe me a quiz. But yeah, so, oops, I don't know how that happened, but okay. So those are the coefficients, right? So if I say, what's the mole ratio of hydrogen to oxygen, you tell me 2 to 1. If I ask you for the mole ratio of oxygen to hydrogen, oxygen to water, 1 to 2. If I ask for the mole ratio of water to hydrogen, it would be 2 to 2, okay? We're looking at the coefficients again for the mole ratio. Now we're going to talk about how to use this stoichiometry pattern chart, okay? So in this blank is going to be any of the following measurements, which are either going to be grams, it's either going to be moles, or sorry, not moles, grams, liters, or particles. Okay? And same at the end, grams, liters, or particles. Okay? So it'll change depending on what the problem asks for and what the problem wants you to find. For example, if the problem starts by giving you grams of substance A, you would put grams here. If the problem wants liters of substance B, you would put liters here. If the problem gives you particles of A, you would put the particle here, right? If the problem wants you to find grams of B, you would put grams here, and vice versa. Sometimes it wants grams of A and grams of B, right? So it'll just depend, it'll change. That's why we're leaving it here, okay, like this. Okay, because it'll change depending on the type of problem being asked. Now in the middle, it's never gonna change. It's always gonna be moles of A and moles of B. Oops. So moles of A to moles of B. And the reason for that is because since you're going from an old compound to a new compound, you always have to switch. So going to a mole to mole ratio using this mole ratio thing. So you're always going to be using the mole ratio in these types of problems in the middle, okay? So now that we have everything we need, y'all can go ahead and rip this paper from the back of your worksheet, okay? And awesome, you can do that. And you can use it for yourself while you solve these types of problems. So now what we're gonna do is we're gonna go over here and we're gonna look at the notes. So, and what we have here is stoichiometry day 2 notes, okay? So elements use atoms, ionic compounds use formula units, and molecular compounds use molecules. So these are the names of the types of particles that are being used, okay? So there are 3 types of particles that we're used to, but we haven't really talked much about when to use that specific particle name. But for elements, so like think of like carbon, oxygen, nitrogen, we would refer to those particles as atoms. When we talk about ionic compounds, and don't forget, ionic compounds are made of metals and nonmetals. So ionic compounds such as magnesium oxide or sodium chloride, when we refer to those particles, we're going to say formula units. And then for molecular compounds, another word for molecular is a covalent compound. Covalent compounds are classified with nonmetals and nonmetals. So something like carbon dioxide, we refer to that particle as a molecule. Okay, so that's just a quick annotation to make. And then here we have our general pattern again. Again, we're either going to be given one of these measurements of substance A. First, we're going to convert it to moles. Then we're going to convert it to substance B using the mole ratio. And then finally, we're going to convert it to something else of B. Okay, so that's going to be our general pattern that we're going to follow when we do stoichiometry. And again, the blank that I left can be filled with grams, liters, or particles, depending on what is being asked of you. So now we're going to go into the model. As you can see, we have a lot of steps, but I broke down everything because I wanted to make sure y'all could follow along like very closely. So let's look at the first question. The first question says, how many liters of oxygen are needed to produce 9 moles of lithium oxide? The first thing we want to do is we want to balance this chemical equation either in our head or using the table method. I'm going to go ahead and use the table method. So table method means we just split this equation in half. We list the elements that we have, right? We're going to look at the subscripts and we're going to count and see how many atoms we have of that element, okay? Whenever you don't see a subscript next to the element, assume you have a subscript of 1, okay? And now we're going to go ahead and check to see if the atoms are balanced. So already I can see that we don't have the same amount of lithiums and we don't have the same amount of oxygens. So what do I want to do? Usually when neither of them are balanced, it's better to start with the element on the bottom because the element on the bottom usually ends up affecting the element that's above it, okay? So all that to say, we're going to start with the one on the bottom. So I want to multiply this by a coefficient of 2. So I'm going to place a 2 here. And that is going to affect my lithium and my oxygen. So timesing the lithium by 2 gives us 4. timesing the oxygen by 2 gives us 2. Okay? Now we can take a look again and check to see if everything's balanced. My lithiums are still not equal, but my oxygens are equal. So oxygen, you can say oxygen's all set. However, lithium is not all set. So what could I multiply this by to get to 4? Well, I could take lithium and multiply it by a coefficient of 4. So 1 times 4 equals 4. Okay? And that's pretty much it. And then since I don't need to do anything to this, we're going to assume that we have a coefficient of 1. 2 times 1 gives me 2. Now, everything is balanced. We have the same amount of lithiums and the same amount of oxygen atoms. And our coefficients are 4, 1, and 2. Okay? So that was the balancing part. I'm actually going to go ahead and I just want to color these purple because why not? So 4, 1, and 2. Okay? And let's highlight those as well. 4, 1, and 2. And that was step 1, which was to balance. Okay? Now that we balanced it, let's read the problem again more closely. It says, how many liters of oxygen are needed to produce 9 moles of lithium oxide? Step 2, we want to identify the given quantity, units, and compound. So I'm going to go ahead and read the problem. So look to see what's given to me, and I can clearly see that I'm given the quantity of 9 moles in the compound lithium oxide. Okay? Lithium oxide is going to be substance A. So I'm going to label that substance A. Okay? What I can also do is label it on my equation so I don't forget. This is going to be substance A. And I could also mark it like this, just so I don't forget if I want. Okay? But yeah, that's going to be my given. Whatever is given to you is always going to be substance A. So just so y'all don't forget, the given is always A. And then the wanted, or what you want, is always going to be substance B. Okay? So step 2 is done. I'm going to check that off. Step 3, identify what you want. So what is wanted? Okay, that's going to be step 3. So question is asking for how many liters of oxygen, right? So this is what we want. What do we want? We want oxygen. Oxygen is going to be substance B. So I'm going to label this substance B. Okay? Off to the side, I'm also going to write it out just so that I can reference it. So the given is 9 moles of lithium oxide. And what do we want? We want to know, question mark, how many liters of oxygen we have. Okay? So step 4, we're going to create a mole map based off of the general pattern. So our general pattern is up here. What I'm going to do to kind of make this easier for you guys to see is I am going to go ahead and write out the mole map first, or the general pattern first. So in orange, I'm going to put pattern. Okay? And for the pattern, all I'm going to do is copy this exact pattern over here. Okay? So we're going to go blank of A. We'll always turn that into moles of A first. Then we're going to turn that into moles of B because we need to change the compound. And then finally, we can convert it to blank of B. Okay? So that's our pattern. Okay? Now what we're going to do is we're going to take our given and our wanted, and we're going to try to see where this fits in the pattern, okay? So they gave us 9 moles of lithium oxide. Remember, lithium oxide is substance A. So I'm going to look at my pattern and see, did they give us a measurement of A or did they give us moles of A? Well, because I have moles here and because we have substance A, this tells me that we're actually starting here. So I'm going to go ahead and I'm going to label this and say, this is where my given starts. Okay? Next, I'm going to look at what we want. Okay? So we want to see, do we want moles of B or do we want a measurement of B? Well, we want liters of B, right? Which means we're going to stop here. And this is what we want, okay? So we are starting from here and we want to convert all the way over here. Because I can't jump all the way over here, I have to convert to moles of B first. So we're going to jump from here to here to here. So that's 2 jumps. That means we need 2 conversion fractions, okay? Let me go ahead and write my mole map now. Okay, so for my mole map, I'm just going to replace the general pattern with the actual given. So my actual given is 9 moles of lithium oxide, okay? The next step is moles of B, okay? Remember, B is oxygen, so we're going to put moles of oxygen, okay? And then finally, we're going to fill this with what we want. We want liters of oxygen, okay? So do you guys see how we're replacing the generic given with the actual given? Substance A with the actual substance A, moles with the actual moles, B with the actual substance B, blank of B, we actually want liters of B, which is oxygen, okay? So we're literally just replacing everything. So now we can actually go ahead and solve. So steps 5 through 9 is the solving steps. So we're going to start with our given, which is 9 moles of lithium oxide, okay? So that step is done. Now we're going to multiply by a fraction, okay? We're going to multiply by 2 fractions because we know we're going to need 2 fractions because we're jumping 2 times, okay? And what I'm actually going to do is I'm just going to follow my mole map. So I started on the right. What's next in the mole map? The next unit is moles of O2. So on the side of this fraction, I'm going to put moles of O2. Okay? So we did this much of the mole map so far. Now we're going to go to the end. What do we have at the end? Liters of O2. So at the top of the fraction, we're going to put liters of O2. Okay? So we have all of the units for the top parts of our fractions. Now we need to figure out where the bottom units go. So what you're going to do is you're going to take your old unit and you're going to move it to the bottom like this. So the moles of lithium oxide have to go on the bottom like that. Okay, y'all see that? Next, we do the same exact thing for the other one. So we're going to take our moles of O2 and we're going to move it on the bottom. Okay, moles of O2. Okay, and that's it. So now we're on step 10. Step 10, we need to identify what quantities we need. Okay, so our options are either going to be the mole ratio or the particles, the mass, or the volume. To figure out what we need, we are going to look at the ratio of units, okay? So let's look at the first fraction. In my first fraction, I have moles over moles, okay? Specifically, I have moles of oxygen over moles of lithium oxide. Whenever your fraction has moles over moles, you're going to use the mole ratio. And remember what we wrote down earlier. The mole ratio is used by looking at the coefficients. So first, we're going to look at the coefficient in front of oxygen, which is a 1. And we're going to write down a 1 here. Okay? Next, we're going to look at the coefficient in front of lithium oxide. The coefficient in front of lithium oxide is a 2. So we put a 2 there. Okay? And then finally, we are going to move on to the next fraction. So we're done with this. We know that this is the mole ratio. Now let's look at this fraction. You're going to notice that we have the same compound now. So we're only going to focus on the measurements, okay? Now, if we look at the units in this fraction, we have liters over moles, okay? Because it says liters and moles, I know that I'm converting to a volume. And if I look at my mole map, 1 mole equals 22.4 liters. So we're going to put 1 on the bottom and 22.4 liters on top. Okay, so what ended up happening? This ended up being my mole ratio fraction, and I know that this is volume because of the mention of liters, and we're going to use the 1 mole and the 22.4. Okay, and so now on a calculator, what y'all are going to do is take 9, multiply it by 1/2, and multiply it by 22.4, and see what y'all get. So let's do that. Scientific calculator, cool. So we're gonna do 9 times 1/2 times 22.4 over 1. Okay, this is what it looks like. And we get 100.8. And so our answer is 100.8 liters of oxygen. Okay. However, we can't forget about significant figures. I have 4 digits in my answer, but we started with 1 digit. So in order to make it one significant figure, I'm just going to leave it at 100, okay? I'm not going to put a dot, right? Because if I put a dot, all the zeros are significant. Leave it without the dot so that only the 1 is significant. And this is our final answer. Okay? So these units, these old units, they canceled out, and we're left with liters of oxygen, which is our answer. Okay? So that is one example of stoichiometry. Okay? What I want y'all to do is pause this video and try this one using the exact same steps. I will tell you right now that for the U-try problem, you're going to actually use the same equation from before. So you're just going to use this equation. Okay? So you're going to use the same equation for the U-try. And it's going to be the same equation in this model. And the same equation down here. Okay? So try this one. So pause and try this one. Okay, we're going to pretend like you unpause. And I'm going to show you how we would solve this question. So I'm not going to use any more color coding just because I feel like it can get a little overwhelming to look at. But the question says, how many liters of oxygen are needed to produce 75 grams of lithium oxide? So I'm going to just go ahead and quickly identify this is my given. And liters of oxygen is what I want. Okay. Now, on the surface, this problem may seem similar because we're still starting with lithium oxide and we still want oxygen. However, this problem is slightly different because before we were given moles and now we're given grams, okay? So let's write the general pattern, okay? So blank of A, moles of A, moles of B, blank of B. Okay, cool. So this time we were given grams of A. So we're not starting here anymore. We're going to start here. okay? So it's blank for a reason because that's where your random measurement goes, okay? So we're going to start here. Okay, turn that into moles of A. Okay, and what do we want? We want liters of oxygen. So we don't want this, we want this, right? We want liters of substance B. So liters goes there, right? So now we're going to substance B, which is still going to be oxygen. And now we're going to liters of oxygen, okay? So this is going to be our mole map. This is going to be our general pattern. Now we can place it in the fractions. Because we're starting from here and we're ending here, we're jumping 1, 2, 3 times. So now we need 3 fractions. 75 grams of lithium oxide. Okay, follow the track. We started here. What's next? This one's next. Moles, lithium oxide. Okay, what's next? This is next. Moles, oxygen. What is next? This is the last step. This one, we're going to put it here. Lithium, liters of oxygen. Sorry about that. Okay, so that's our setup. Now we just need to bring the old units down diagonally. Okay, so the first unit we're bringing down is this one. Okay, we're going to place grams of lithium oxide here. The next unit we're bringing down is this one, moles, lithium oxide. And then the final one is this one. We're going to bring it down there, moles of oxygen. Okay? Now we're at step 10. We need to identify what quantities go where. So again, remember we're dealing with mole ratio, volume, particles, or mass. Okay? Let's take a look here. Okay? Let's look at this ratio. We have moles versus grams, okay? Anytime you deal with moles versus grams, that's always going to be molar mass, okay? So we know we have 1 mole of lithium oxide, and we need the molar mass of lithium oxide down here, okay? Now, if you look at your mole map, when you're trying to find the molar mass of a compound, you need to add all of the atomic masses together. So you need to add the 2 lithiums and you need to add the oxygen together, and that's going to give you the molar mass. Okay, I'm not going to do that yet. I'm going to save that for last. We're just going to move on to the next fraction. Okay, our next fraction says mole over mole. So that means mole ratio. So we're going to look at the coefficient in front of oxygen and the coefficient in front of lithium oxide. So we're going to zoom out. Oxygen is 1, lithium oxide is 2. So that gives me 1 over 2. Okay? Now we move on to the last fraction. So we have this, okay? We have liters versus moles, meaning we're working with volume. 1 mole equals 22.4 liters, okay? So I almost have everything, right? The only thing that I am missing is the molar mass of lithium oxide, okay? So we're going to go here, okay? Now you need to use your periodic table. Find the molar mass of lithium. I think it's 6.94, right? So lithium oxide has 2 lithiums, so I'm going to add another 6.94. And then finally, it has an oxygen, which has a molar mass or atomic mass of 15.999. So you can see we got the 2 lithiums and the oxygen, and that gives us a molar mass of 29.879. Okay, so that means here we got 29.879. Okay, so now we can take everything and multiply it in the calculator. So we're starting with 75 grams times this fraction, times this fraction, and times this fraction, okay? 75 times 1 over 29.879 times a half times 22.4. We get 28. So our answer is approximately 28 liters of oxygen. Okay, again, the old units cancel out. So you can cross them out if it helps you remember. And then we always land at the unit that we want at the end. Okay? So that was the U-Try example. Wasn't that fun, guys? I know it was so fun, wasn't it? Okay, we have another model now. So model, how many grams of lithium were used if 3.01 times 10 to the power of 23 formula units were produced? Okay, so for this one, it's kind of hard to tell what's given and what's wanted here. So we're just going to go really quickly. We're going to label our equation. So the reactants are on the left. Our products are on the right. Okay, so reactants are going to be your lithium and your oxygen, right? Your products are going to be your lithium oxide, okay? So let's try to see what was given to us. We got this many formula units. This many formula units were produced, okay? So that's going to be our given. 3.01 times 10 to the power of 23 formula units, okay? Of, well, does it tell us the compound? It doesn't tell us directly. However, the word produced is a key word. So any word produced or product implies that it's talking about your product. And what's your product? Lithium oxide. So that means that our given compound, compound A, is going to be lithium oxide. Okay? And then the question is asking for grams of lithium. So what we want is, we want to figure out how many grams of lithium we have. Okay? So substance A is lithium oxide. Substance B is lithium. Okay? So I'm going to go ahead and write out the general pattern again. Okay? And if y'all want, y'all don't have to write it out, but if it helps you, you can. Okay? So since we were given formula units, I'm going to place that here. Okay? So I know I'm starting here. And since we want grams of lithium, I know we're going to stop here. Okay? Okay, so now I can set up my mole map. I'm going to have to write kind of small. 3.01 times 10 to the power of 23 FUs of lithium oxide. Turn that into moles of lithium oxide. Turn that into moles of lithium. And finally, grams of lithium. Cool. Okay, let's see, how many fractions is that? 3 fractions. Start with your given and multiply by a fraction. Okay, we're gonna follow the map. So we got 3 fractions. And we're gonna write this here, and this here. Okay, next step, cancel out the old units. I'm gonna draw the arrows so y'all don't forget. Okay, now we need to figure out what our quantities are. Okay, let's look at the first fraction. First fraction says moles over formula units. That's a particle. I need to use Avogadro's number. 1 mole of lithium oxide equals 6.02 times 10 to the 23 particles of lithium oxide, or F formula units, okay? Next fraction says moles over moles. I need to use the mole ratio of lithium to lithium oxide. Let's look up here. So lithium is 4, lithium oxide is 2. Okay. Finally, we have this fraction, which is grams of lithium over moles of lithium. This is going to be molar mass. 1 mole will equal the molar mass of lithium. For molar mass, you always have to look at the atomic mass of the element on the periodic table. So lithium has a molar mass of 6.94. And now you can multiply it all and get the answer. It's going to take a minute. .01 times 10 to the power 23 times this fraction 1 over Avogadro's number times 4 over 2 times 6.94. Okay, you're probably wondering, Ms. Silverio, why is this the same answer as the molar mass? Well, this number is half of Avogadro's number, so you could reduce this fraction to a half. 4 over 2 is 2, a half times 2 is 1, 1 times this ends up equaling the same number. Isn't that funny? I think it's so hilarious. Dun, 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 dun. Okay, so that's funny. Our answer ends up being 6.94 grams of lithium. Okay, so you may be wondering, on a question like this, how many points would this question be worth on a free response? Great question. You would get +1 point for balancing. You will get +1 point for starting with your given, +1 point for Avogadro's number, +1 point for mole ratio, and +1 point for molar mass, +1 point for correct answer rounded to the correct units, and +1 point for the units grams of lithium, okay? Your units have to be specific. You have to tell me that your answer is lithium, because if you just leave it as grams, I don't know which compound you're talking about. So just make sure you're specific. So in total, this type of question would be worth 7 points, right? 1, 2, 3, 4, 5, 6, 7. Yeah, 7-point question. Wow, isn't that fun? Okay, I want you to pause this video and try this one on your own. I'm going to pretend you pause the video now. Okay, I'm going to pretend you unpause the video. So how many atoms are produced from 9.28 moles of lithium? I am going to go over this one a little bit more quickly. Sorry about that. Y'all just going to have to get with the program. Atoms produced. Okay, let me actually lower this a little bit. Just to remind y'all, reactants are on the left, products on the right. Okay, so products is this. This is what we want. Reactants are this. We are given lithium. Okay? So, mole map. Okay? So, we were given moles of A. So, we were not given blank of A. So, we're going to start with moles of A. Okay, after moles of A, we have moles of B. What's B? B is the product because it says how many are produced. So we're going to moles of product, moles of B. And then finally, what do we want? We want atoms of B, atoms of product. Okay, so this is a two-step, okay? We didn't start with grams or any of the other ones, so we're starting with moles, so it becomes a shorter problem, okay? So, times the two fractions. Move everything down. Okay, here we have a mole to mole ratio, so 2 to 4. And here we have atoms to moles, so that's Avogadro's number. Okay. Now we need to solve that on the calculator. 9.28 times 2 over 4 times 6.02 times 10 to the power 23. 2.79 times 10 to the power 24. So the answer is this. Atoms. Oh, wait, actually, never mind. Okay, I think, I just realized this problem's messed up. Oh my God. Okay, I just realized something. So remember what we said earlier about like ionic compounds? Their particles are formula units, right? So this isn't supposed to say atoms, right? This is actually supposed to say formula units, okay? So we're just gonna change that real quick. Okay. And we're gonna take this a step further. Okay. So if we look at this compound, okay, how many atoms are in this compound? Well, we have 2 lithium atoms and 1 oxygen atom. So what's 2 plus 1, guys? There's 3 atoms total in here. So yeah. So we have to multiply everything by 3 because there's actually 3 atoms in the compound itself. Where did everything go? Okay, so times by 3. This is our answer. 8.38 times 10 to the power 24 atoms. Okay. And what does that mean? So because this, again, atoms and the ionic compound doesn't work, it's actually FUs. Okay? But you can turn FUs into atoms. So then it looks a little different. Okay? So it doesn't follow the general pattern. It actually goes, it extends even further. But If you didn't do this fraction, don't worry about it. Just don't worry about it because I'm never going to be crazy and give you something like this. So I'm not going to try to trick you or mess you up, but it is my job to give you the correct answer so that it would be the correct answer. But I can't believe I even caught that. But yeah, that's pretty much it. You do have the 7.2 exit ticket. I put 5 attempts on there. A lot of people are not doing well because they're not putting the units in the answer. And you also have to have the right significant figures in the answer, okay? So try your best. I am going to extend the deadline like to 2 days because obviously I'm not here and we're just going to be doing more of this when we get back, okay? So I hope you guys enjoy and good luck.